In this lesson, we're going to finish that Units 1 through 9 assignment packet. So we're going to start at question number 27, and we're going to integrate, and it's not obviously going to tell you how to integrate. You're going to have to try to recognize what it might be. And what do I look at? So for number 27, the first thing I look at is it's a fraction. And so to integrate a fraction, I think it could be a logarithm. I also see something squared plus 1. So it also has that template of arctangent. So I'm going to start with a logarithm because it's easy to test. Take the derivative of the denominator. Is it like terms with the numerator? So the derivative of the bottom is 2x. The top is x. They're like terms. So I can use a logarithm to integrate. So I need it to be 2x, which means I need a fraction 1/2 in front. And then I start with 1/2 ln, and then it's x squared plus 1 plus c. Done. Let's look at another one. This one. How am I going to integrate this? So the first thing I notice is a square root sign. So I'm going to write that to the exponent 1/2. Then I'm going to look at the base and know that the derivative of the base is 2x. So I need to make it 2x. And then what fraction undoes that in front is 1/2. The 2x goes away. We start with 1/2. And then I do the anti-power rule. And now the anti-power rule is you add 1 to the exponent. So 1/2 plus 1 is 3/2. And then divide by that number or times the reciprocal. You don't have to reduce it down, plus c, but the 2's do divide out. 29. There it is. So I already noticed that I have something to the exponent 3. So what I'm going to do is this. I'm going to do just a little bit of algebra. That 3 belongs to both. So 1 cubed is just 1. And then I could have done this in one step, but I'm going to show you in 2. So that 3 belongs to both. That's a good first step. Then we're going to write it calculus friendly. And so 1 over that, another way to write that is x plus 2 to the exponent -3. The derivative of the base is 1, so the hook is perfect. So all I have to do is the anti-power rule. Add 1 to the exponent, and then divide. Number 30, here we go. So what do I notice? So e, I want to look at the exponent. So when I look at the exponent e, if I zoom in, I see x cubed. So the derivative of x cubed, subtract 2 is 3x squared. So I need a 3 in front. That means what fraction do I need in front of that? So it stays the same, 1/3. So then I can circle 3x squared. The hook goes away. And I start with 1/3. The rule for e is you copy it. Plus c. Number 31. Recognize that a and b are constants, and we just have a dx. So for this one, again, the first thing is when I see a fraction, it could be an arctangent, arcsine, it could be a logarithm, or you might have to write it calculus friendly. In this case, the derivative of the denominator is just a. So I need an a here, which is a number. And then to undo that a, I need a 1 over a in front. So the derivative of b is 0 because it's a constant. A represents a number like 2x or 3x or 4x, whatever that number is. So the derivative of ax is a. Then I need to know what was it before, 1, and over what it became, which is a. Then I can see it's a logarithm. So then I write down ln ax plus b plus c, abc. 32. So what's the first thing I'm drawn to? So the first thing I'm drawn to is this exponent 3 and trying to understand what it means. The second thing I'm drawn to is I understand the derivative of secant is secant tangent. So I need that fact. The derivative of secant is secant tangent. So when I write this, I'm going to write secant 2x all to the exponent 2. But you said there's a 3. Well, that extra secant is going to go beside I had a little room there. So do you see how there's 3 secants? But I separated it in a way, so the derivative of secant is secant tangent. So I needed that extra secant for the hook. Now there's still another little hook, and that little hook is 2. So I need a 2 in front, so the fraction that undoes the 2 is 1/2. Then this whole caboose here at the end goes away, that whole hook. And I'm going to start with 1/2, and then the rule for secant squared, the antiderivative, is just tangent. Oh, the 2 goes away too. That's part of the hook. So I just write down, oh no, sorry. I don't actually use that because it's in the form secant 2x. It's actually an anti-power rule, not worrying about tangent. So add 1 to the exponent, and it's now 3, and then divide by that, plus c. The more we practice, the more you'll see similar techniques that show up more and more, and you'll be more comfortable to go, what direction do I go when I see it? But it does come with practice. And so I'm hoping that when I do these videos and you practice with me, it makes you more confident. But eventually you're going to have to try it yourself. So 33, do you want to try to integrate that, or do you need me? It's up to you, but if you could try, press pause and try it, and then press play. So first thing I notice is I want to know what the derivative of pi subtract x is. Pi is a constant, so the derivative of pi is 0. The derivative of negative x is -1, so it needs a negative and then a negative in front. So did you see that to begin with? Then, once I do that, what is the antiderivative of sine? And the antiderivative of sine is negative cosine. So when you go negative cosine, it's actually going to make it positive. So I'll even go times negative cosine pi minus x plus c, and recognize the negative times the negative really just makes it positive cosine, pi minus x plus c. Okay, 34. You try, and then I try. So press pause and recognize what you could do with it. All right, so the derivative of this is 0 e to the 2x times 2. So I could make this 2x and then 1/2. Then this goes away, and I should be able to write down 1/2 ln 1 plus e to the 2x. Oh, you know what I can't do there? The problem is the exponent. So e to the x and e to the 2x. I felt something was wrong. It was like the Force from Star Wars. It said, don't do it that way. So the derivative of e to the 2x is e to the 2x times 2. Well, I can't just magically make e to the x e to the 2x. So this is the wrong direction. So what's another way we can do when it's a fraction? And another way is understand it might be arctangent. So let's try that one. Maybe some of you did arctangent and then go, oh, I made a mistake. It was me. So a is the square root of 1. Simple. U is the square root of e to the 2x. Now, how do I do that? Well, the square root means to the exponent 1/2. And that simply means you multiply these exponents together. So 2 times 1/2, or the square root of this, you just end up with e to the x. So notice how 2 times 1/2 just leaves you with x. And then what would u prime equal? Well, the derivative of e to the x is e to the x. So when I look here, I have exactly the hook I need on top. It matches. So my answer then would be for arctangent. It fits. And arctangent starts with 1 over a. Well, 1 over 1 is just 1. Then it's arctan. And then inside would be u over a. My u is e to the x over 1, just e to the x, and then plus c. All right, number 35. Can you find the average value of this function? So the word average value means I'm first going to do what? Integrate. I wonder if you could set this up. It's from 0 to pi over 3. What am I integrating? Just tangent x. And then what do I divide by? Pi over 3 subtract 0. So that just the setup would give you a point on the AP exam. Then, how do I then actually do what it's asking me to do? So you actually end up with just pi over 3 in the denominator. So if you like, you can write the reciprocal of that. Then you don't have to worry about the fraction. So pi over 3 really becomes 3 over pi. And then how do you integrate tangent? So what is there a rule for that? So oh yeah, that's sine over cosine. So it's negative ln. Do you remember that one? So it's going to be negative ln cosine. And then I'm integrating from 0 to pi over 3. So you're able to remember the rule, the antiderivative rule. Again, for these questions, you should have those 4 or 5 sheets of paper out that has the rules on it. So if you know you're integrating and you forget, go to the piece of paper, go to your reference sheet. And every time we practice, when we get closer to May, you can take those sheets away and you'll be able to know it because you've been practicing regularly. All right, what's the last step to get our answer? And the last step is simply a substitution. So negative ln cosine pi over 3. Subtract. Now, when you subtract the negative, it's really going to be adding. That's why it's adding. And again, ln cosine 0. And that's it. It is free response. I'm not even going to do the next step for you. And there's your answer. Here we go. Next question. It says find the area. So when it's asked for the area bounded, is that a derivative question or an integration question? That's first step. So most of you recognize it's an integration question. Is this going to be pi r squared? Nope, that's when we revolve. So it's just top subtract bottom. So find it, and we're given a function, and then it's simply bounded by the x equals 1 to 4. So 1 to 4, and then you have x squared plus 1 over x and 0. So I can tell that this is above. So when you plug in numbers 1 to 4, this is always going to give you a positive answer. It's always going to be above 0. So it's x squared plus 1 over x dx. You could go subtract 0 if you like, subtract top, subtract bottom, and these give you your bounds. There's step number 1, and you get a point. Next step, do you know how to integrate this? So when it's a fraction, what are you thinking of? Is it a logarithm? Well, the derivative doesn't match. And the next thing I think of, I'm not going to go to arctangent or arcsine, not that, but what I do notice is that the numerator is a degree bigger than the denominator. And then you think, oh, is that long division? Well, it could be, but I see a monomial on the bottom. And when I see a monomial on the bottom, I can then separate it and go x squared over x. And x squared divided by x is x. And then the second part is 1 over x. So do you see how I separated the monomial? So x squared over x and 1 over x. There it is. Then when I integrate that, that's a whole lot easier. The integration of x is x squared over 2. And the integration of 1 over x is ln x. And again, I'm integrating from 1 to 4. And then the last step, just plug in. So the first thing you plug in is 4. Use parentheses. Subtract, use parentheses, then you won't make a silly algebra mistake. And it's over. All right, number 37. It says set up an integral for the volume, but it says don't integrate. So it's just a setup. So we know we're going to do an integral for the volume of the solid that we just did. So we know we're going from 1 to 4. How are we doing the volume here? The base is that region and whose cross section. So we're not revolving. If we're revolving, then it would be pi r squared. But what are they? They're squares perpendicular to the x-axis. So I need to remember what's the formula for a square. So you take one base of that square and you square it. Now not pi r squared, not a circle, just the area of a square. And then you need to recognize what represents the base at any point between 1 and 4. And the answer is x squared plus 1 over x. That is the base. Done. All right, last page. All right, a Diffie-Q. So two things I can almost promise you is that there'll be a Diffie-Q on this calculus exam, even the 45-minuter that you'd be doing, or the 4-hour one later in life. But there's going to be a Diffie-Q. So can you do a slope field? Can you do a differential equation? So sketch a graph of the particular solution which contains the points 0 and -2. There it is right there. Now, what are some things I notice about the slope field? I notice the x-axis is empty. So as I am curving up to the left, right, and trying to follow that, I recognize that here is going to be a hole. And then what I recognize here is that it flattens out to the right, and you can sketch it through 0 and -2. That's the sketch of the solution. Then, could you do it algebraically? So, first step is, could you separate the variables? So I'm going to multiply both sides by y and both sides by dx. Next, I'm going to integrate this. So y becomes y squared over 2. The integration of 1, you don't see it, is just x, and then plus c. I'm going to multiply everything times 2, and then instead of 2c, I'm going to replace that with a single constant, c2, and then the square root. Now, I know that the y-coordinate is negative, so when I take this and solve it, it's going to be a negative in front when I do that. So there's the equation. I have a particular solution because I know a point. So the y-coordinate is -2. The x-coordinate is 0. So then we just plug in and solve. So the negative and the negative, they divide out. So I just get 2. 2 times 0 is 0. So you're left with this. And then how do I undo the square root? Is square both sides. So C2 is equal to 4. And then the last step is to rewrite the equation. -2x plus 4. And you have the skill to solve a Diffie-Q algebraically and using the slope field and drawing it on there. All right, number 39. Find an equation of the line tangent. So a tangent line. So that definitely means I should go x equals, y equals, and m equals, just to have a structure to what I'm doing. I'm told that x is pi over 4. Y, well, if I plug in pi over 4 here, I get 2 root 2 sine pi over 4 plus 2. I have no desire to simplify that. I could, but I'm not going to. So I just want to show if it's free response what would be expected of you. And then the slope would be the derivative and plug in pi over 4. So the derivative of sine is cosine. So it'd be 2 root 2 cosine x. And then the derivative of 2 is 0. So that's all it is. And then substitute in. And what x value do you put in is pi over 4. So now you have all the values. A little bit awkward, but way better than having to pretend you know your unit circle perfectly. Maybe you do. Then we write down y equals the slope, 2 root 2 cosine pi over 4. X subtract pi over 4 plus 2 root 2 sine pi over 4 plus 2. And there's the equation of a tangent line. And if it's free response, you're not needed to simplify that. It says find a point on your tangent line from problem number 39 to give an approximation for 1. So if I want to approximate 1, then all you do is substitute in positive 1 to find that. So the approximation of this then would be 2 root 2 cosine pi over 4, 1 minus pi over 4, plus 2 root 2 sine pi over 4 plus 2. And there's no need to simplify it unless it was multiple choice. Now, just for fun, if it was multiple choice, the cosine of pi over 4, well, pi over 4 is at 45 degrees. It's root 2 over 2. So if I had 2 root 2 times root 2 over 2, what would that become? So the 2's divide out, and root 2 times root 2, all of this would just be equal to 2. And then I would have x minus pi over 4. Same thing here. The value of sine at pi over 4, same exact value because it's 45 degrees. So root 2 over 2, if I simplify it, just becomes 2. And we have 2 plus 2 at the end, which makes it 4. So this is what it would look like if you simplified it. Then if I plug in 1, 1 take away pi over 4, like a dollar take away 1/4, leaves me with 3/4, but it's pi. And that's a great answer. Yes, you could write it a little bit differently. All right, on number 41. We're almost there. 2 more questions. So a particle moves along a straight line with acceleration. So we're given acceleration of this. And when t equals 1, the velocity is 5 and its position is 10. And then it says find an equation for the velocity. Step 1. If you have acceleration, how do you find velocity? So the velocity is the integration of the acceleration. So there's step 1. So how do I integrate it? So the acceleration is 1 over t squared. So already, I'm not going to write it as 1 over t squared. I'm going to write it as t to the negative 2. And that means the velocity, you add 1 and divide. So add 1 and divide plus c. Now, does it give you information to be able to find out what c equals? Yep. It says when t equals 1, what is the velocity? 5. So the velocity is 5. I'm going to put in 1 and solve it for c. So this looks a little complicated, but 1 to any exponent equals 1, and 1 divided by negative 1 is negative 1. Add 1 to the other side, and what does c equal? And c equals 6. So what is the velocity? If I summarize this, it would be negative t to the negative 1, that's what that is, plus 6. All right, part B, what does it ask? Find an equation for the position. So we'll use the letter x or s for that. So I'll use x for that. So the position of the particle would be the integration of the velocity. So how would I integrate the velocity? I have negative t to the negative 1 plus 6. So to integrate this, again, it's the anti-power rule. So add 1 to the exponent. Wait a second. If I add 1 to the exponent, negative 1 plus 1 is 0, and divide by 0, I'm not going to blindly do that. That's not the direction. So this is special. Remember that t to the negative 1 is just 1 over t. And if I integrate 1 over t, that's a special one, and that is a logarithm. So we're going to do a logarithm, and there's a negative in front. So it's negative ln t, absolute value. So you try to add 1 and divide. That doesn't make sense. So then what? It's special. In this case, it's a logarithm rule. And then 6 is just 6t plus c. Next, what do we know about the position? Again, when t equals 1, the position is 10. So we make it equal to 10. And then where there's a t, I put in 1. And then I solve for c. So ln 1 is 0. Meaning if the base is e, what exponent gives you the answer 1? 0. This is 0. Ln 1 is 0. 6 plus c is left. Subtract 6, and c is equal to 4. So if I summarize what this is, the position of this particle is, the equation, it would be negative ln t plus 6t plus 4. All right, number 42, and this is what's going to end for today. So 42, find the x values of the discontinuities of this on the interval from 0 to pi. So if I was going to do that and understand the discontinuities of it, I need to know where the asymptotes are for secant. So if you think of the graph for secant and think of the unit circle, I think that'd be helpful. Let me just draw a little unit circle here. So here, remember, it's the reciprocal of the x-coordinate. So the x-coordinate's 1, the x-coordinate's 0, the x-coordinate's -1, and then back to 0 again. When it's 0, that's when it is there's an asymptote. There's a discontinuity. It's not continuous, if I can say that right. So what are those angles at the top and bottom? So the first angle is pi over 2. So if I take secant 2x and understand that, I actually don't need the secant part. So first angle is pi over 2, but we have a 2x in here. So I'm going to make it equal to 2x. To get x by itself, I divide by 2. So that'd be pi over 4. And the problem with pi over 4 is not, is it in my, yeah, it is in my interval, 0 to pi. So the first angle is pi over 4. I'm going to do it again. So the next one would be at the bottom, which is 3 pi over 2. Make it equal to 2x, divide, and you get 3 pi over 4. There's the next one. There could be another one, but I can see a pattern already. It's going to be pi over 4, 3 pi over 4. The next one would be 5 over 4, and that's going to be beyond my interval. So the only two answers where it is not continuous is at pi over 4 and 3 pi over 4. Number 42 is a pre-calculus question, just for the fun for today, not calculus, and not directly would you be asked that on an AP exam. All right, Mr. G Math, over and out. I am so proud of you that you're still working at this. Bye.